Welcome back to Be Spice. In this session, we'll discuss about a new topic, cyber vulnerabilities in industrial control system. So this is the topic we are going to focus. So we'll focus on all the vulnerabilities in the sense architectural and design, configuration and maintenance vulnerability, physical vulnerabilities, and software development vulnerabilities, and vulnerabilities in communication and network configuration. All these aspects we will dive deeper. Okay. Let's go into the detail, or rather agenda. I'll just touch upon a bit of intro. Then I will focus on the architectural and design vulnerabilities. Then we'll move on to the configuration and maintenance vulnerabilities. And of course, physical vulnerabilities will just, touch upon very on a surface level. We are not going into deep. Software development and communication and network configuration will be dealt deeply. Okay. So, introduction. Okay. See, as you know, friends, remote attacks often serve as an initial point of entry for targeting ecosystem of devices, right? So, the point is here, attackers take advantage of known vulnerabilities in specific protocol implementation using readily available pre-written attack scripts, simplifying the attack process. That is what they do actually, right? So by monitoring a non-encrypted, that is the point. See, if it is encrypted, they cannot break, right? So if by monitoring the non-encrypted traffic, attackers can gather valuable information about the system, enabling them to escalate the attack and eventually gain control over the targeted device. That's what they do. So, as you can see from these things, this emphasizes the significance of implementing a robust security measures, isn't it? So, what sort of measures, including encryption, routine vulnerability assessment to fortify defenses against cybersecurity, cyber threats, yes, and ensure the protection of critical industrial systems, right? Okay, so yes, so indeed, attackers actually targeting industrial control system rely on exploiting one or more existing vulnerabilities. So we'll see all these vulnerabilities. What are all those vulnerabilities? So one is the architectural and design vulnerabilities. Friends, in this deficiency in overarching system architecture and design can be leveraged by malicious actors to obtain unauthorized access or manipulate control process. This is one of the aspects. So you can you can understand how proof the architecture should be. Of course, we are going to discuss detail. Then the second is about configuration. Friends, I am only touching about the surface level. The next slide I will go into detail. So the second is configuration and maintenance vulnerabilities. Here incorrect or inadequate system configuration and of course the poor maintenance practice can create opportunities for attackers to compromise the system security. That's about the configuration. Then physical. Of course, as I said, I'm going to talk about the only surface level. Physical access to industrial control system can lead to potential exploits, such as unauthorized tampering with hardware or gaining direct access to critical components. That is the physical vulnerabilities. Then when you talk about the software development, errors or flaws in software development can introduce vulnerability so that the attackers, they may exploit to infiltrate and, compromise the system. Then when we talk about the communication, insecure communication protocol and improperly configured network can provide attackers with entry points to intercept or manipulate data and control commands. So this is just an intro part actually. Okay, friends? So I will just dive deep into each of these aspects, except the physical vulnerabilities. Okay. So when we talk about the architecture and design, okay. So basically, inadequate incorporation of security into architecture and design during the design phase, right? So incorporating security into the architecture and design of ICS should be considered from the outset. That means from the design inception stage itself. So that is the issue. That is a challenge actually, because of the constraints of the budget, schedules, all these. Okay. So the point is we need to incorporate the security into the architecture and design of the ICS. The security architecture should be integral to overall enterprise architecture. That is the point. Okay. Yes. So to effectively address the security concern, the ICS must encompass several aspects. What are all those aspects? One is the identification and authorization of users. See, basically, friends, here, robust authentication mechanism should be in place to verify the identity of users accessing the ICS, right? Authorization procedure must guarantee that the users are allocated appropriate privilege in accordance with their designation, roles and responsibilities, right? That's what identification and authorization of users. Then access control mechanism. Access control mechanism, policies and mechanisms should be implemented to restrict and manage users' access to critical components within the ICS. Thereby, this ensures that only authorized personnel can interact with a specific system, right? So that is another aspect we should focus on. Then network topology, network topology. See, the network topology should be designed with security in mind, meaning network segmentation, firewalls, and other security measures should be deployed to prevent unauthorized access and isolate the critical component from less secure area. So that is the point. Then system configuration and integrity mechanism. Implementing system configuration control and integrity mechanism ensures that ICS operates within the specified parameters, that any authorized changes or tampering are properly detected and addressed. These are the aspects we can talk about this inadequate incorporation of security into architecture. So we should focus on identifying and authorization of users, access control mechanism, network topology, and system configuration. Okay, friends? I hope you got some insights on this. Okay, right. So the point is to sum up, okay, maybe, yeah, to sum up actually, by proactively integrating this security consideration into ICS architecture design, okay, organization can build resilient and secure, okay, system that protect against the cyber threats. That is the point. Then the second point, insecure architectural design permitted to evolve. Okay. See, the network infrastructure of ICS has frequently evolved and adapted to meet business and operational needs, right? Yes. So with often, sometimes, without sufficient consideration of them, potential security consequence. So because of this, security vulnerabilities may have unintentionally emerged in certain parts of the infrastructure. So that is the point. So in the absence of corrective measures, these vulnerability could serve as a potential point of unauthorized access into the ICS. So that is the point we should take. Then the third one, security parameter, not perimeter, sorry, security perimeter not defined. Friends, without a clearly defined security perimeter for the ICS, it will be challenging to guarantee the proper deployment and configuration of essential security measures. This results in unauthorized access to system and data along with other potential issues. That is the added challenge here. Then one more challenge. We are talking about architectural design. Okay. So one more challenge here is inadequate collection of event data history. Investigative analysis relies on gathering and preservation of ample amount of data, right? In the absence of thorough and precise data collection, determining the cause of a security incident may become exceedingly difficult or even sometimes, impossible. So security events have the potential to go undetected, leading to additional harm and disruption. So the point is consistent security monitoring is equally crucial for identifying issues related to security control, such as misconfiguration and malfunction. So this is what I have for this architectural design and vulnerabilities. We should focus all these actually. I'm talking about the vulnerabilities. So you can see what sort of vulnerabilities are available in our system design. Okay. Then we'll go into the configuration and maintenance vulnerability. So as part of that, we will talk about operating system. Friends, operating system, we call it as OS, right? And application security patches are not maintained, or sometimes, vendor decline to patch vulnerability. So outdated, operating system and application may house newly uncovered vulnerabilities that could be taken advantage of. So it is of utmost importance to create a documented guidelines for overseeing the security patch management. In situation, if where unsupported ICS operating systems are utilized, access to security patch support may not be available, isn't it? So consequently, what we can do, these procedures should also incorporate backup plan for addressing vulnerability that may never receive prompt patch updates. So operating system is one of the gray area, right? Okay. Then OS and vendor software patches. This vendor software patches may not be developed until a considerable time after security vulnerabilities are initially discovered. So due to the close integration between the ICS software and the ICS infrastructure, any modification must undergo extensive and time-consuming regression testing. Okay. So yeah, incurring significant costs. Of course, we have to. The duration required for this testing and subsequent distribution of this software can create a prolonged window of vulnerability. So the point is, so vendor software patches needs to be addressed. Okay. Then installation of malicious software. Of course, this you all know actually. So the installation of malicious software, we call it as a malware, right? Is a prevalent form of attack, right, friends? So installation of malicious software or malware is very common. So malware protection software such as antivirus must be kept in a dynamic environment. Outdated malware protection software and definition open the system to new malware threats. So we need to keep updated. Okay. Then insufficient examination of security modification. See, introducing a modification to hardware or a firmware or a software without conducting prior testing poses a risk to the smooth operation of the ICS, isn't it? So it is very important to establish a well-documented procedure for evaluating the security ramification of changes. So the point is, it is very vital to refrain from using operational system in live environment for testing. Additionally, the testing of system modification may necessitate collaboration and coordination with system vendors and integrators. So these are the aspects we should focus on with respect to the examination of security modification. Then another one, inadequate remote access management. There are various reasons why remote access may be required for an ICS. Maybe a system maintenance task performed by vendors or a system integrator or ICS engine is accessing geographically distant system component. To safeguard against unauthorized access, it is essential to maintain robust control over remote access capabilities. Friends, pertinent to this, vendors like Siemens, they actually want to access their, turbine or the systems from their remote place. So this is just one example. In such a case, we need to have a, remote access capabilities. I mean, robust control over the remote access capabilities. Then critical configuration are neither stored nor subjected to backup procedure. See, for example, procedure for restoring ICS configuration should be easily accessible to address unintentional or malicious configuration alteration, ensuring system availability and data protection. So it's very important to establish thorough and meticulously documented procedures for maintaining the configuration setting. You got it, friends? Yes. So then unsecured information stored on the portable devices. This is also another challenge. See, the security of the system could be compromised if confidential information such as password or dial-up numbers is stored without encryption on a portable device such as laptop or mobile devices. To minimize this risk, it is essential to implement policies, procedures, and mechanism to safeguard this data, isn't it? Yes. So that is the one more point. Okay, that's all. Okay, few more to add on the configuration. Yes. So another one is password generated, replaced, and safeguarded are not are inconsistent with policies. Yes. So the extensive knowledge about password management in IT is relevant to ICS, right? So maintaining effectiveness requires strict compliance with password policies and procedures. Okay. Of course, many companies are into it, and yeah, we need to ensure this also. Then insufficient access controls. See, access control should align with how the organization assigns responsibility and privileges to its personnel, right? Poorly defined access control can grant an ICS user too many privileges or restrict them excessively. That is also one of the area we need to focus. Then absence of configuration management for hardware, firmware, and software, right? The organization may lack visibility into its inventory, the versions in use, their location, their patch status, resulting in an inconsistent and ineffective security posture. To safeguard an ICS against inadequate or improper modification, okay, as for example, during, before, during, and after system implementation, right? So it is essential to establish a structured process for controlling changes, to hardware or firmware or software or documentation. Failing to institute these configuration change management procedure can introduce security oversights, vulnerabilities, and risk. So the bottom line is to comprehensively secure an ICS, maintaining an accurate inventory of system assets and their configuration is very, very, very essential. Okay? Because these are essential for implementation of business continuity and disaster recovery plans, isn't it? Yes. So then another point, improper data linking. Data storage system within ICS can be connected to non-ICS data sources, right? So for example, you see, one is a database link. Basically, it facilitates automatic replication of data from one database to other. However, incorrect configuration of data linkage can introduce vulnerability, potentially enabling unauthorized access or to manipulation of data. Okay, so this is improper data linking. Then another one which we all know, malware protection, deployed without thorough testing. That is the main point. See, if malware protection software is deployed without testing, then it has a potential to disturb the normal operation, right? So yeah, that's it. Then again, denial of service. We call it as a DOS. ICS software might be prone to DOS attack, leading to obstruction of unauthorized access to system resource or disruption of the functions and operations. Okay, right. This is denial of service. Then lack of installed intrusion device and prevention software. See, as we all know, incident can result in system availability and integrity loss, right? Data capture, modification, deletion, everything, right? Here, IDS or IPS, IDS, intrusion detection, or IPS, in prevention software, may stop or prevent various type of attacks, including the DOS attack, denial of service. So, yes. So IDS and IPS software must be tested before deployment to determine that it does not compromise the normal operation of the ICS. So that point also we need to note. Then few more to add on in this configuration, lack of log maintenance. In the absence of accurate log, pinpointing the cause of a security incident can become a challenging risk task, right? Yes. And another one is unauthorized personnel have physical access to equipment. See, limited physical access to ICA should be exclusively granted to essential personnel while considering the safety prerequisite such as emergency shutdown or restart. Inappropriate access to ICS can result in any of the what do you call any of this any in the sense theft of data or physical harm or destruction of data, unauthorized alteration to the operational environment, and disconnection of physical data link and untraceable interception of data. All these actually. So that is why we should have the authorized personnel to have a access. Then we have this radio frequency, electromagnetic pulse, and static discharge and voltage spikes. You know, is of course you know this control system hardware is susceptible to various threats, right? Including radio frequency interference, EMP, electromagnetic pulse, discharge, static discharge, all these, right? And spikes. So the consequence can vary from temporary disruption of command uncontrolled to irreversible harm to circuit board. So the point is, it is advisable to implement adequate shielding, grounding, power conditioning, and surge suppression measures. You got it, friends? Yes. Then lack of backup power. In the absence of backup power for essential assets, a widespread power outage can result in ICS shutdown. I hope you agree. So potentially creating a hazardous situation, right? Additionally, the loss of power could result in activation of insecure default settings also. That is also one of the challenge. Then finally, in this configuration and maintenance vulnerability, physical ports lacking security measure. This is very common. Unprotected USB could permit unauthorized connection, right? Thumb drives, all these, right? That is what I meant here. So this is all about the configuration and maintenance. Now let us move into the software development vulnerability. Okay, it's very simple. Two items are there. One is inadequate data validation. ICS software might fail to effectively validate user inputs or incoming data for accuracy, potentially leading to various vulnerability, like buffer overflow or command injection or so many things actually, right? So inadequate data validation is one of the challenge. Then the second is installed security features remain inactive in their default setting. See, that is the another challenge. See, the security feature bundled within the product become ineffectual unless they are actively activated or at a minimum acknowledged as disabled. So we need to have this need this security measures active actually. We cannot leave it just like that. This is about the software development. Then finally, the communication and network vulnerability. Under this communication network vulnerability, we'll talk about unused data flow. The data flow controls are essential based on the attributes of the data because they help to regulate the transfer of information between system, right? So this plays a crucial role in preventing data exfiltration and unauthorized operation. So the point what I'm saying is unused data flow. So we need to have a data flow controls, right? That is a point. Then we also need to have this another reason, sorry, inadequate firewall and router logs. In the absence of precise and comprehensive log, identifying the root cause of a security incident might become a big challenge. That is a point. Then the third item for this communication is standard, well-documented communication protocols used in plain text. That is the biggest challenge, See, see now, if this is not encrypted, right, then it will be a challenge actually. Yeah. See, there are many, protocol and other utilities. We can use it to decode the transfer data over protocols such as, files transfer protocol, FTP, or hypertext transfer protocol, HTTP, or NFS, network file system. All these we need to utilize to decode the data transfer over protocols. Okay. The challenge here, since these protocols do not employ encryption, the data transmitted is easily readable by anyone monitoring the network. Thereby, this exposes the sensitive information, including the login credentials and commands sent between devices, potentially leading to unauthorized access and manipulation of the ICS network. So this point also we need to take note. Okay. Then another one is the firewalls, which we all know. Okay. See, firewalls are either absent or configured incorrectly. Insufficiently configured firewall can lead to unrestricted data flow between diverse network, such as control and corporate network. Okay. This actually can create openings for potential attack, right? And also spread of malware across the network, ultimately exposing them sensitivity data to potential monitoring and allowing unauthorized access to system. So we need to have a firewall which is configured. Okay. Then authentication of users, data or devices are either inadequate or entirely absent. Okay. See, numerous ICS protocol lack authentication at any level. Okay, in the absence of authentication, there is always a possibility of data or device manipulation, right? So that is what we need to focus also. Then absence of communication integrity verification. See, friends, most industrial protocol lack a built-in integrity checker, potentially allowing adversaries to tamper with the communication without detection. To ensure integrity, what we have to do, ICS system can implement low layer protocol like IPsec, which provide data integrity protection. So the point is we should implement a low layer protocols for protecting the data and integrity. Then we have another challenge, insufficient authentication measures between wireless client and access points. See, what we have to do, it is essential to establish a robust mutual authentication between wireless client and access points. Okay, from connecting, access point deployed by adversaries. See, additionally, this authentication ensures that adversaries cannot connect to any other ICS wireless network. Okay. So that's all, friends, I have on this actually. Hope you got some insights into the cyber vulnerabilities in industrial control system. Just to recap, we talked about the architectural and design, and we also touched upon configuration and maintenance, physical, software development, communication network. So the idea of this video is to, just to enlighten you on this issues, cyber vulnerabilities, so that when you design, when you configure, you can take all these precautions. So that is a point. Okay. Right. Thank you. Thanks for watching, and can show your support by either way by pressing the thumbs up button or becoming a subscriber or becoming a member. Okay. Thank you and see you in next video. In fact, I want to actually talk about see here it is more of a cyber vulnerabilities in industrial control system as a whole. Next topic, what I intend to do is cyber vulnerabilities in industrial protocol. So protocol in the sense of DNP3 protocol, Modbus, IEC, IEEE, all these OPC, all these I'm planning to discuss. Thank you. Take care. Bye-bye.